Welcome all of you. Today we have to discuss nuclear magnetic resonance spectroscopy in this interpretation of spectra we see. First of all, identification of number of signals is the most important in NMR spectroscopy. So let us see with the example. First one example is the ethyl bromide. Ethyl bromide contain two types of proton. One is the CH3 and another is the CH2. So, one signal for the CH3 and one signal for the CH2. Therefore, total number of signals in ethyl bromide is the 2 signal. See the next one example. Example number 2. In this, so many types of protons are the present: CH3, CH2, CH2, CH, CH3, like that. So, first of all, we see about CH3, CH3. These both the CH3 are in same chemical environment. What is meant by same chemical environment? Because this CH3, both the CH3 is attached to the CH protons on one side, on another side as the free, because this is the terminal CH3. So, both the CH3 is attached to the CH proton and this CH proton is attached to the CH2. So, the chemical environment of both the CH3 groups are the same. Therefore, both the CH3 shows one signal in NMR spectroscopy. See here, this one example also contains the another CH3 group, but this CH3 group is attached to the OCH2 group. Therefore, these first one CH3 groups are in different chemical environment comparison to these first one CH3 groups. So, the number of signals counting in this example, one for CH3 groups and second one for the two CH3 groups. There are the two signals. See here, two CH3 groups was also present in this compound, but these two CH3 groups means this one CH2 groups is attached to the OCH2 and one CH2 group is attached to the CH group. Therefore, both the CH2 groups are in different chemical environments. Therefore, this gives the different signals. So, the total number of signals in this is first one signal for the CH2 group, second one signal for this CH2 group, third one signal for this another CH2 group, fourth one signal for this CH groups, and fifth one signals for these two CH3 groups. Therefore, total number of signals is the 5 signals. See the next example, toluene. My CH3 group is attached to the benzene ring. So, see here. In case of toluene, one signal is for the CH3 group. So, see here, this benzene ring is the symmetrical. So, due to symmetrical properties, the hydrogen which was present on both the sides of the benzene rings are in same chemical environment. Why this is in same chemical environment? Because on one side this CH group is attached to the carbon atom containing CH3 groups, and on another side this CH group is attached to the CH group. Also from this one side, this red one CH group is attached to the below one CH group. So these CH groups which I highlighted is attached on both the side at CH group, and on that one side is also attached to the carbon atom bearing CH3 groups. So the chemical environment on both the sides of these highlighted CH group are the same. Therefore, these highlighted CH groups gives only a one signal because this is in same chemical environment. Like that, this below one CH group, which was also present on both the sides, also are in same chemical environment. On above side, this is attached to the CH. On below side, attached to CH. This one side CH group is also attached to CH on both the side. Therefore, this below were highlighted CH group is also are in same chemical environment and gives a one signal. So, total signals in this toluene, one for the CH3 group, another for both of these hydrogens on both the sides. So, third one signal for both this hydrogen and fourth one signal for this remaining hydrogen. So, total number of signals in this toluene is the 4. See here the next one example containing the double bond. When there is a presence of a double bond, we consider the stereochemistry like cis and trans. Consider this example containing the CH3 group, CH3 group and CH3 groups. But these three CH3 groups are in different chemical environment. Why? Because see, let us one by one. These CH3 groups is cis is the geminal CH3 group of this hydrogen. Next one CH3 group, which is the trans CH3 group with corresponding to this hydrogen. This one CH3 group is the cis CH3 groups corresponding to the hydrogen. So in this way, all these three CH3 groups are in different chemical environment. Therefore, number of signals in this example is 1 for CH3 group, 2 for this CH3 group, 3 for this CH3 group and 4th one for this CH protons. So total number of signals is the 4 signals. See the next one example. In this next one example, also there is a symmetry is present. Due to this symmetry, this compounds is divided into the two equal halves. Due to these two equal halves, the CH3 CH2 groups was present on both the sides, and this CH3 group is attached to the CH2 group. This one CH3 group is attached to the CH2 group. So in this way, both the CH3 groups are in same chemical environment. Similar way, this CH2 groups is attached to the CH3. This one CH2 groups is attached to the CH3. Therefore, these CH2 groups are also in same chemical environment, and these two hydrogens groups is also attached to the carbon atom bearing double bond. Therefore, these two hydrogens are in also same chemical environment. So total number of signals in this compound is for first one signal for this both the CH3 groups, second one signal for both of this CH2 group and third one signal for both of this hydrogen. So total number of signals is this 3 signals. So consider symmetry while evaluating the number of signals is the most important criteria. Symmetry simplifies spectra. This one is the more important word here while evaluating the number of signals. So see here, acetone. The molecular formula of acetone is this acetone contains the two CH3 groups, but this two CH3 groups is attached to the C double bond O group. Therefore, both the CH3 are in same chemical environment and nothing is present another type of proton. Therefore, total number of signal in acetone is 1 only. So, in the NMR spectra gives a 1 signal. See here, this is the example of methyl acetate. Methyl acetate contain CH3 group which was attached to the C double bond O group and another CH3 groups which is attached to the oxygen atom of the ester. Therefore, both the CH3 groups are in different chemical environment. Therefore, gives the different signal. So, methyl acetate contain one signal for the CH3 proton and another signal for the OCH3 proton. In this way, two signals are appeared in the NMR spectrum of the methyl acetate. The n plus 1 rule means multiplicity rule. The multiplicity of a proton or a group of proton is given by the n plus 1 rule, where n is the number of proton on the adjacent carbon atom. Here we discuss about the spin-spin splitting of the proton in NMR spectroscopy. So see here, if the adjacent carbon atom containing the one proton at that time n plus 1 rule, according to n plus 1 rule, if the value of n is equal to 1, therefore 1 plus 1 is equal to 2. So 2 means doublet and the intensity patterns of this doublet is 1 as 1. In this way, if there is a 2 number of protons was present on adjacent carbon atom, so the value of n is equal to 2. So according to n plus 1 rule, this is the 2 plus 1 is equal to 3. 3 means triplet. The splitting pattern is the triplet and intensity of these 3 lines is 1 as 2, 2 as 2, 1. In this way, if the number of adjacent carbon atom bearing hydrogen is 3, it gives quartet. Adjacent carbon atom bearing 4 number of hydrogens, it gives quintet. 5 number of hydrogens gives sextet and 6 number of hydrogens gives a septet. Let us now we discuss about how to analyze the NMR spectra. See, first one example is example of ethyl acetate. Means CH3, C double bond O, O, CH2, CH3. First of all, we discuss about how many number of signals we obtain. So see here, number of signals is 1 for the CH3, 1 for the CH2 and another for the CH3, because both the CH3 are in different chemical environment. One CH3 is attached to C double bond O and another CH3 is attached to CH2 group. Therefore, both the CH3 are in different chemical environments. So, total number of signals is the 3. So, this is the spectra in front of you. In this spectra, this is for the CH3 and number of proton here is the 2.94, means near about the 3. So 3 protons gives triplet. 3 protons gives triplet. See here, this is the clear spectra. 3 protons gives triplet at delta 1.2. This triplet is evaluated according to the n plus 1 rule, because this CH3 protons is attached to the carbon atom which bearing a 2 number of hydrogens. So according to the n plus 1 rule, 2 plus 1 is the 3. Therefore, this CH3 protons gives a triplet. at delta 1.3. In the similar way, this next one CH3 protons gives singlet because this CH3 protons is attached to the carbon atom which does not wears the hydrogen atom. Therefore, this CH3 proton gives the singlet at delta is equal to 2, and below this indicates the number of protons. See here, this is the number of proton 3 and this gives the singlet. Next one, OCH2 protons. This OCH2 protons, this CH2 group is attached. CH2 group is attached to the CH3, means 3 hydrogens, and on another side there is a no hydrogen, so 3 plus 1 is the 4. So this CH2 group gives a quartet according to n plus 1 rule. According to n plus 1 rule, so this CH2 group which bearing the 2 number of protons when 1.9 is near about 2 gives the quartet at delta 4.2. This is the highly de-shielded proton. This is because of this CH2 group is attached to highly electron withdrawing oxygen group. Next example is the ethyl pentanoate. In this ethyl pentanoate, see here again same one. This contain the 2 CH3 groups. These 2 CH3 groups are also in different chemical environment. So this compound also contain the 2 CH2 groups. These 2 CH3 groups are in also different chemical environment. So number of signals in this is 1 for CH3, 1 for CH3, 1 for another CH2. This is for another CH2 and 1 for CH3. So the number of signal is the 4. So see here one by one. CH3 proton is adjacent to the CH2 proton, means 2 plus 1 is equal to 3. Therefore, these both the CH3 protons shows triplet at 3 protons. See here, this below 1 value is the number of protons. 3 point something means 3 protons are present on that one carbon atom. So both the CH3 groups shows triplet. CH2 group both the CH2 groups is attached to the CH3 groups, means neighboring carbon atoms containing the 3 hydrogen. So according to n plus 1 rule, 3 plus 1 is equal to 4. Therefore, this CH2 groups gives the quartet. So both the CH2 groups, this one CH2 group also gives the quartet for the 2 protons, and this one CH2 groups also gives the quartet for the 2 protons. There is a difference in the values. One of the CH2 group is the highly de-shielded, and this highly de-shielded proton is the OCH2 group. This one example is also shows the number of signal is the 3. See here, this is the example of the aromatic chemical compound, and the name is the secondary butyl benzene. This aromatic compounds, the number of protons is the larger. So see here, CH3 groups are in different chemical environment. Another signal for the CH2 group, next one signal for the CH, and in aromatic compound the signals is also given by the hydrogens atoms which was present on that one carbon atom. So in this way 5 hydrogens was present in this aromatic rings. So the total number of signals is This 5 hydrogen atom gives the one signal when they are in same chemical environment. But see here, these 2 hydrogen atoms and these 3 hydrogen atoms are in different chemical environments. So this 3 hydrogen atoms gives the one signal and these 2 hydrogen atoms gives the another signals. So the total number of signal, one for the CH2 and one for the CH3 in aromatic ring. Another CH3 gives one signal, means 2 signals from the aromatic ring, third one signal from the CH3, another signal from this another CH3. So 4 signals, fifth one signal for the CH2 and sixth one signal for the CH. So see, this CH3 gives the one signal, another CH3 gives one signal, CH2 protons gives one signal. Here is the one hydrogen, this is the CH, and these are the 5 protons of the aromatic rings. So in this way we analyze the NMR spectra. Thank you.